bread and butter, a classic combo and one of my favorite snacks. After I've buttered a beautiful slice of white sandwich bread, the very last thing I want to see is the labor of love landing butter side down on the floor. Turns out I'm not alone. In fact, the myth originated in ancient Rome, where parents were said to fret over their children's toast falling and landing butter side down on the floor. In those days, such an incident forecast bad luck. I tend to agree with the ancient Romans. Sometimes after I drop my bread on the floor, I feel like my day's been ruined. I've decided that I'd like to optimize my bread's chances. What precautions can I take to ensure a more favorable outcome if my buttered bread were to drop on the floor? Let's conduct a well-controlled experiment to find out. Before we conduct the experiment, it's important to discuss the factors affecting the bread's chances of landing butter side up. One critical factor to consider is the manner in which the bread falls to the floor. The bread could be thrown in the air. Oh no! It could be dropped from midair. Uh-oh! And lastly, could be, I'm gonna grab the juice. Oh, knocked off the table. Shoot. Since the most common drop seems to be the knocked off the table drop, this is the manner in which I will drop the tested bread. With this drop method, it is important to observe that one side of the bread tips over the edge of the table, causing the slice to rotate while it falls. With this in mind, we now have another factor to consider. The number of rotations the slice cycles through depends on the duration of the fall, determined by the height of the table the slice falls from. In addition to the height of the table the bread falls from, I've also decided to test whether the amount of butter spread on the slice will impact its chances of landing butter side up. In a Mythbusters episode, it was observed that bread with an indent in the middle had a greater tendency to land butter side up. Perhaps more butter spread on the slice will cause the bread to cave in the middle, thereby enhancing its chances of landing butter side up. As I mentioned earlier, the drop height of the table the bread falls from determines the number of rotations the slice will cycle through. When dropped from a shorter height, the slice does not have enough time to undergo a full rotation. Thus, since the bread starts out on the table butter side up, it will most likely land buttered side down on the floor. The bread's only saving grace may come from the amount of butter spread on the slice. A large amount of butter could create an indent in the bread that may alter its rotation pattern. Based on the knowledge that I have obtained through background research and preliminary observations, I hypothesize that buttered bread is more likely to land butter side up if it is knocked off of a higher table and spread with a large amount of butter. To test my hypothesis, I have created 3 conditions that I will apply to the bread slices, and I will test the conditions from 2 different drop heights. The slices of bread receiving condition 1 will serve as the control group, thus condition 1 refers to the application of no butter. I will mark one side of each of these slices with an X that will count as the bread landing up. Condition 2 slices will be spread with 1 tablespoon of butter, and condition 3 slices will be spread with 2 tablespoons of butter. I'm using 1 loaf of bread for each condition, and each loaf contains 20 slices of bread. The first tested drop height will be from a coffee table with a height of 20 inches, and the second drop height will be from this bar, which is 43 inches tall. I will use a scale to measure the weight of butter applied to each slice in order to ensure equal amounts within each condition receiving butter. I will also attempt to knock the bread off of the surfaces in the same manner to eliminate differing forces applied or drop methods used as artifacts. Alright, as you can see here, we've got all these slices of white sandwich bread from Target on sale. And what we've done is we have applied condition 1, which, although is a lot less tasty than conditions 2 and 3, it is necessary to serve as a control for this experiment. All we had to do to apply condition 1 was this handy dandy Expo marker and just make nice little X's on each piece of bread. And we are going to kick off the experiment finally with condition 1, the control group, and we're going to use our coffee table, which is 20 inches tall, to serve as the first drop height, which I did mention earlier. And we will set the slice of bread near the edge of the table with the X facing up, since the X represents the butter side, and the butter side will be facing up when testing conditions 2 and 3. I will knock the bread off the table using moderate force, and I will use the same surface of my hand each time. And once the slice of bread lands on the floor, I will see which side is facing up, whether it's the up side or the down side, and I will make the corresponding mark in my data table, which I will show later. Alright, this is our coffee table, which is 20 inches tall, and here's our bread, which has condition 1 applied, just the X marked on one side. And I'm going to do the knock off the table drop method, which, as we mentioned earlier, causes the rotation motion because one side of the bread ends up over the edge of the table. And in this case, since the table is shorter, I'm guessing that it's not going to be able to complete a full rotation, so it should land buttered side down since it starts butter side up. So I'm going to use the outside of my hand and apply just the normal force that I would if I were to knock a piece of bread off of my table when I was eating breakfast or lunch. So here I go, here's my bread. Oh no, shoot, what a bummer. And as we can see, this is the side without the X, which is buttered side down. And what I'm going to do is I've got my data table here, and this is the butter side up or butter side down slid off of the coffee table, which is 20 inches in height. And I have my 0 tablespoons of butter table, which is the control group, and this is trial 1 out of 20, and I'm going to put a mark in the butter side down box. So I'm going to complete this with control group 20 more times, and I will report my results at the end of this video. Alright, this is the scale that I'm going to use to make sure I use the same amount of butter on the slices of bread within each condition. If I look at the package of butter, it says that 1 tablespoon, which applies to condition 2, is 14 grams. So what I'm going to do is turn on my scale here, and it is in grams, so that is good. I'm going to slice off a little bit of butter over here. That's not enough, clearly. We've only got 0 grams. Alright. So, it'd be easier to have 2 hands for this. There's 13 grams. There's 15, too much. And there's our 14. So what I'm going to do now is I'm going to evenly spread the butter across the bread because I don't want any uneven spots because that could affect the rotation of the bread. So I'm going to evenly spread it and then it will be ready for testing. Alright, conditions 2 and 3 have been applied. Here is the buttering station. It's a little messy. Over here we've got condition 2, which is the 14 grams or 1 tablespoon. Looking pretty evenly spread, I would say. Now if we move on over here, we've got our condition 3, which is 2 tablespoons, 28 grams. You can see it's a little thicker of a coat, still evenly spread. Also, we are painting, so that's what we've got going on back there. But yep, so I'm going to take each condition separately over to the coffee table, which is 20 inches high, once again, and we will see how they fall. Alright, here we are with condition 2 ready to be tested, which is our bread butter side up with 1 tablespoon of butter or 14 grams that was measured on the scale, which you saw previously. I've got my bread on the edge of the table here, and my special helper, here he is, just helping me out. And what I'm going to do is knock the bread off the table in the same manner I did with the control group, using the outside of my hand. Okay, so moderate force just like we previously saw. Here we go. Is it going to be butter side up or down? I don't know, we'll find out. No, shoot! That's what I was expecting. Are we still going? Alright, that's what I was actually expecting to happen. because this is just really a terrible situation for us and our bread, because the bread simply does not have enough time to rotate, to complete a full rotation. So it's almost just bound to land buttered side down. Shoot. Alright, now I have the condition 3 bread, which has double the amount of butter, 2 tablespoons, 28 grams. And what I noticed on our last trial with condition 2 was that both of the ends, the crust ends, they're slightly concave and they both landed butter side up. So that's kind of what I think might happen with these. I don't know if it's enough butter, but I'm thinking that it will make the bread sort of indent more since there's more weight on the bread. And maybe that will increase its chances of landing butter side up. We will see. So this is our first piece of condition 3 bread. And I'm going to do the same motion outside of my hand with the same force. And unfortunately we got butter side down, but I'm going to keep trying 19 more times and I will report my results at the end of this video. Alright, here we are back at the bar. And if you recall, it is 43 inches tall, which is more than double the height of the coffee table. And right here, I have our slices of bread that have been applied with condition 1, which is no butter, just an X made with an Expo marker. What I'm going to do is set the bread on the corner of the table, just like I had set it upstairs on the coffee table. I'm going to apply the same motion, or try my best to, and use the same surface of my hand with the same force. So what I'm thinking is that the greater distance the bread has to fall, that it will have more of an opportunity to complete a full rotation and potentially land with the butter side up, or in this case the X side up. So here we go with condition 1. It landed with the X, or what represents the butter side up. So I'm going to do this 19 more times with condition 1 and record the results. Okay, so I've applied conditions 2 and 3 to 2 different loaves of bread. And I've got condition 2 right here, which is the 1 tablespoon of butter. And I've got my slice of bread on the edge of the table. And like I said previously with the control group, I'm thinking that this bread will have a greater chance to land butter side up since it has a greater duration of time to complete a full rotation. This one does have butter on it, unlike the control group, so we'll see how that affects anything. But here we go. I'm going to knock it off the table and see how this one lands. Actually, I'm going to move this bag out a little bit because I don't want to make a mess on the carpet. You're welcome, Mom. Here we go. That one landed butter side down. So I'm going to do this 19 more times and we will see what our results tell us. Now I have my condition 3 bread, which has 2 tablespoons of butter, 28 grams. And what I was thinking when I formed my hypothesis was that the extra butter would create the indent in the bread and maybe enhance its chances of landing butter side up since it would have that concave shape. So also the height should help it. In my thinking, it would have more ability to perform a full rotation. So here we go. I'm going to knock it off the edge of the table and let's see what happens. Butter side down. We'll do this 19 more times and we will record the results. Now that I have finished conducting the experiment, I compiled the data into these tables that are more conducive for conducting the chi-squared value, which I will use to determine whether the results obtained were statistically significant or not. In this first table, here's an example of how I used the chi-squared equation. This is for the condition 1 slices here. The equation for chi-squared is the sum of the square of the observed values minus the expected values all over the expected value. So in this case, for condition 1, I for the butter side up, I observed 5 slices landed butter side up, and I would have expected 10 if it were due to chance. You take that and square it, divide it by 10, and then take the sum of that using the butter side down. Do the same thing, I observed 15, and I ended up with a chi-square value of 5. So this doesn't mean much to me right now, but you can use this table, and we had a 1 degree of freedom, and we're going to use a p-value of 0.05, and that means I need to look at this number here, 3.841, and determine whether my chi-squared value is greater or less than that number. So I had 5, it is greater than 3.841, and that would allow me to reject a null hypothesis, or in other words, I can conclude that my results were due to factors other than chance, and the results were statistically significant. I used this same equation for each of the other conditions, conditions 2 and 3, and plugged them in just like I did in this example up here. And I found for condition 2, I got 3.2, which was less than the 3.841 that I was comparing to in this table. And then I got 7.2, which was much higher, and that allowed me to come up with the conclusion that at a drop height of 20 inches, the bread which received conditions 1 and conditions 3 landed butter side down more often than would be expected by chance alone. Condition 2, on the other hand, did not land buttered side down enough times to attribute the results to factors other than chance. Looking at my data in the 43-inch drop height table, I used the same equation and went the same process that I described just earlier, and I came up with the conclusion that at a drop height of 43 inches, the bread which received conditions 2 and 3 landed butter side down more often than would be expected by chance alone. Condition 1, on the other hand, did not land butter side down enough times to attribute the results to factors other than chance. We discussed the results and what I was able to conclude based on the statistical significance or lack of statistical significance of the results, but what exactly do these results mean and how do they apply to my original hypothesis? My original hypothesis stated that buttered bread is more likely to land butter side up if it is knocked off of a higher table and spread with a large amount of butter. Upon analysis of the results, however, condition 3 bread, which received the greatest amount of butter, served as the only condition to land buttered side down more often than not, with statistically significant results attributable to factors other than chance alone. Not only did the increase in butter fail to enhance the bread's chances of landing butter side up, but the height increase did not seem to help the situation either. My original idea was that the increase in weight spread on the slice would cause the bread to form a dish in the middle, and this would possibly alter the bread's rotation pattern, enhancing its likelihood of landing butter side up. I came up with this idea after I watched Mythbusters try the experiment. I think the flaw in my thinking stems from the fact that I used untoasted bread and Mythbusters used toasted bread. Perhaps the act of toasting the bread created the curved shape, not the amount of butter applied to the untoasted bread. In this experiment, the increase in butter seemed to prohibit the bread from performing a full rotation from a greater height, causing it to land buttered side down more often. Possible experimental errors may have come from the fact that although I did try my best, I'm sure I didn't knock every slice of bread off of the surfaces using the exact same motion and force each time. Due to human error, some slices may have received a greater amount of force, or I may have hit the bread in a different location each time. If I were to conduct this experiment again, I would devise some sort of contraption that would knock each slice of bread off of the surfaces in the same manner each time.